Hey, what's up? We're going to look at velocity time graphs, and it's easy to confuse these with distance time graphs, so we're going to be really careful that you look at the axes and you just think about what you're doing. The secret to velocity time graphs is realizing that the gradient is the acceleration. So looking at these graphs that we have in front of us, velocity time graphs on our axes. So remember, gradient is acceleration. Here is a constant gradient. So constant gradient equals constant acceleration. Here, we've got zero gradient, so the acceleration is equal to zero. Here, the gradient is negative, which means we have a negative acceleration, which we call a deceleration. The steeper the gradient, the higher the acceleration. So this has a greater acceleration than this line here. Really simple. Gradient is acceleration, and always remember to use the word constant. Right, if we have a look at graphs though, which are curved, you have to be really careful. But if you remember the fact that gradient is the acceleration, it's actually quite easy. So first of all, looking at this green line, it's got a steep gradient and it gets shallower and shallower. So it is a reducing acceleration. It's always accelerating, but at a reducing rate. Secondly, the red line, it starts off shallow, then gets steeper and steeper and steeper. It's got an increasing acceleration. Remember, the gradient is the acceleration. I'm going to keep saying that over and over. If we look at curves going the opposite way, we know that going down in velocity means a deceleration. So looking first of all at the red line, it starts off steep, then gets shallower and shallower. So the red line is a decreasing deceleration. Now, secondly, looking at the green line, it starts off shallow, then gets steeper and steeper. So the green is an increasing deceleration. Really important, as I keep saying, to remember that the gradient is the acceleration. If you remember that fact, all of this becomes so simple. Right, now we're going to use the fact that the gradient is the acceleration. And the formula A equals change of velocity over change in time, which actually means the same thing. So from A to B, if we want to calculate the acceleration, what I want to see everyone do in exams is drawing these triangles, because these triangles are your working out, which show that you know that the gradient is the acceleration. So the change of velocity here is 60, and the change in time is 10. So A is change of velocity divided by time, which is 60 over 10, which is 6 meters per second squared. B to C, the gradient is 0, so the acceleration is 0. It's a horizontal line. If we look from C to D, you just got to be a little bit careful here just to draw your triangle properly. I always label my change of velocity. So change of velocity here is 20, because it's from 80 down to 60. And the change in time is 5. So C to D, the acceleration is the change of velocity over time, which is 20 over 5, which is 4 meters per second squared. Finally, from D to E, we've now got a deceleration, which means we're going to get a negative number. And that's because the change in velocity is minus 80 this time. It's gone from 80 down to 0. So the change of velocity divided by time is minus 80, and the change in time is 5 seconds. And that gives us an answer of 80 divided by 5, 16 meters per second squared. And that's negative because it's a deceleration. Okay, at A level, you're expected to be able to calculate the acceleration from a curved graph. So if I take this point here, point A, and I want to measure the acceleration at that instant in time. It's a curve, so the acceleration is changing, so we have to talk about instants in time. The first step is to draw your tangent, which is your red line. Secondly, you draw your dotted lines, and then you calculate the gradient. So the gradient is equal to the acceleration, which is your change in velocity divided by time. The change in velocity here using the scales is 52 meters per second. And the change in time, looking at the scales, is 26 seconds. So we do 52 divided by 26, which is 2 meters per second squared. You could do the same at this point, and you can see that it's a shallower tangent. Therefore, it's going to have a shallower gradient and it's going to have a lower acceleration. Finally, the last bit that you can do from velocity time graphs is you can work out the displacement, and the area underneath the curve is equal to the displacement. So I'm going to separate this graph into 4 separate areas. I've got area 1, area 2, area 3, and area 4. Area 4 is negative, it's in the negative quadrant, so we're going to have to take it away. Right, just a bit of basic maths here. So area 1 is half times the base times the height, which is half times 5 times 20, which is 50 meters. Area 2 is a rectangle, so we do base times height, which is 5 times 20, which is 100 meters. Area 3 is half times the base times the height, because it's a triangle, which is half times the base, which is 6.5, times the height, which is 20. And if I just get my calculator and work that out, 0.5 times 6.5 times 20, which is 65 meters. And now we've got area 4, which we've got to remember is negative. So we do half times the base times the height, which is half, times the base, which is 3.5, and the height is minus 10. 0.5 times 3.5 times 10 is minus 17.5. So if we want to know the total the displacement travelled, S equals area 1 plus area 2 plus area 3 plus area 4. So we do 50 plus 100 plus 65, take away 17.5. And I always do everything on my calculator so I don't make mistakes. So 50 plus 100 plus 65, take away 17.5. And that gives me a total distance of 197.5 meters. So really easy. The area is the displacement, and you just got to calculate each area individually. So in summary, all we've got to remember is the shapes of the graphs. This first one is a constant acceleration. The second one is a constant velocity, or acceleration equals 0. This third graph is a constant deceleration. When the graph is curving up, we've got an increasing gradient, so that's an increasing acceleration. This here is a decreasing acceleration. The next graph is an increasing deceleration. And this one here is a decreasing deceleration. And the way we look at that is just by looking at the fact that the gradient is acceleration. If you analyze the gradient, it becomes really easy. If you've got a curve, use a tangent to determine the gradient. Finally, the last fact to remember is that the area is equal to the displacement. And if that graph goes below the axis, you just got to take that area away. So that's it. Velocity time graphs, nice and easy. Just remember the key facts and just be really careful you're working out. Thanks for listening. See you all soon.